Hey guys, I'm Manjunath Naik. I'm a first year student at China Agriculture Engineering College. Before I start off, let me ask you a question first. If I ever wanted to measure diameter of this bottle's cap, I would use a measuring tape or a measuring scale. But then I would get a very approximate reading. To get an accurate one, I'd use something called Vernier Caliper. Vernier Caliper is one of the most efficient and accurate device used by engineers. It can be used to measure inner diameter of a pipe, outer diameter of a bottle's cap, or even to measure depth of something. Let me explain various parts of vernier caliper. These are the internal jaws used for measuring internal diameter of a body. These are external jaws used for measuring external diameter of a body. This is known as stem, also known as depth measuring blade, used for measuring depth of a body. This is the main scale. This is the locking screw for locking things, and this is the vernier scale. So now let's learn how to use a vernier caliper. Suppose we want to measure the external diameter of this bottle's cap. We place this in between the external jaws. There are different ways to read different types of vernier caliper. For example, in this vernier caliper, the main scale reading reads 53 mm and the vernier scale reads 0.24 mm. So the final answer would be 53.24 mm. If I wanted to measure using the traditional vernier scale, I would do this. 10 units of vernier scale is equal to 0.9 centimeter. That means 1 unit of a vernier scale is equal to 0.09 centimeter. Suppose if I wanted to measure the length of this block, I would keep this block here and then close the jaw. Then I would measure the main scale reading. In this case, the main scale reading is 1.5 centimeter. The line of the main scale that is coinciding with the vernier scale. In this case, this is the 8th line of the vernier scale that is coinciding with the main scale. Now what I do is, as I need to find the distance between the 0th line and the 1.5 here, what I'd simply do is multiply 8 by 0.01 centimeter, which gives me 0.08 centimeter. The distance between these two lines, the 0th line and the 1.5 here, is 0.08 centimeter. I would simply add that to 1.5 over here, and that gives me the length of this block, which is equal to 1.58 centimeters. If I wanted to measure the length of this new block, I'd check the main scale reading, which is 0.8. I'd check the vernier scale reading that is coinciding with the main scale. Here it is the second line. Then I would multiply 2 into 0.01, which gives me 0.02 centimeter. Then I would add 0.02 centimeter to 0.8, which gives me 0.82 centimeter, which is the length of this block. So that's how a traditional vernier caliper works. This one over here is an upgradation over that, because this can measure more accurately. Nowadays we have digital vernier calipers which are even more accurate. However accurate a device may be, it's the user's accuracy and the ability to read a device that counts. For example, one of the most common mistakes made while reading a vernier caliper is parallax error. You should not look into the vernier caliper from a different angle. You should directly look into the vernier scale to avoid the parallax error. For example, if you look at it from a different angle, you might see that the reading changes. So this is one of the most common mistakes made while reading a vernier caliper. And second mistake is that you should not keep this thing loose. Like sometimes what you do is you tend to keep some space between this bottle's cap, so the reading might be more than the expected reading. So always make sure that you tighten it and then take the reading. Third, you should not move much while taking the reading, as your movement may alter the readings and may cause errors. Make sure that there is no zero error. Now what exactly is a zero error? Zero error is an error where your supposed theoretical value should be 0, but your practical value is not equal to 0. For example, look here, there's nothing in between these two jaws, so the supposed theoretical value should be 0. But take a close look at this. The pointer is not exactly on 0. That means that there is some zero error. To negate the zero error, make sure that your practical value is equal to 0 when your supposed theoretical value should be 0. This ensures that there is no zero error in your reading. Vernier caliper finds its uses in a lot of industries, for example in automobile industry or in any other industry where length, breadth and height of an object is very important. Vernier caliper is also used in many other fields like in medicine field where height or breadth of an human body is very important. It is also used in laboratories and nowadays you can find it in any school physics lab. And I would like to thank Namrata ma'am, our physics professor, for guiding me through this project.